Welcome back to Posse Empowerment.
Welcome back to Exploring the Style Design-Based Architecture series.
I'm Lidu.
And I'm Kema.
And we are the co-founders of Little Steam. This week is all about the math behind architecture. Before we get on to the video, remember to stay safe during the pandemic.
Yeah, make sure you follow the rules.
Alright, let's get on to the video.
Hey Lidu, I forgot what architecture was. Can you just remind me of the definition again?
Yeah. Well, architecture is the art and science of planning, designing, and constructing buildings and other structures.
Oh yeah, I remember that. That was easy peasy. But how does this relate to math?
Well, let me ask you something, Kema. Are you in your house?
Yeah.
How big is your house?
I know it's bigger than me. Probably bigger than most people's houses. I don't know.
Do you think if your house was as big as a Lego set, you would fit in it?
No way. I'm way too big for that.
Exactly.
Oh, I think I know what you're trying to say.
Yup. Math has to do with numbers and measurements, and we need that in architecture to build things that make sense and are ultimately the right size.
Let's learn more.
Do you know what geometry is, Kema?
Yes, I do.
Geometry is essentially the study of shapes.
So what does this have to do with architecture?
Well, architects apply geometry into their designs.
Oh, I want to see some examples.
Yeah, let's put them on the screen.
That was so cool. Now that I think about it, geometry really is everywhere. My door is shaped like a rectangle, my doorknob is shaped like a circle, and my chair has a bunch of rectangles all over it.
Yep, Kema. Geometry really is evident in our lives.
Okay, what's next?
Unit conversion.
Oh Lord, I'm terrible at all of this stuff. At least I know what it is.
We'll spit it out.
Well, because Americans in like these two other like tiny little countries or something like that use the customary system, we usually have to do a lot of things where we convert our math over to match with the rest of the world.
Well, a good example is converting feet to meters. A little more than 3 feet equals 1 meter.
Well, okay, now that we know what that is, and why does this have to do with architecture?
Well, metric conversions are a very important part of the design process because it tells us how much matter we need, like the length of wood and how a building will be built. So, how much space we will need basically is what it helps us understand.
Wow, that's very important. We wouldn't want to have a building that's way too small, like you said with the Lego example.
And we wouldn't want to have a building that's way too big. Imagine if you ran out of flooring. That would not be very good. All right, we're going to talk about one more thing, Kema.
What's that?
Trigonometry.
That's a weird word.
Yeah, it really is a weird word. Actually, people call it trig for short.
Alrighty, cool. So what's trig?
Trig is basically the mathematics concerned with angles.
That's cool, but what do angles have to do with architecture?
Trigonometry is used in architecture to ensure that buildings are built safely.
Like,
Architects have to calculate precise angles of intersection of their structure to ensure stability and safety. Here are some photos with unique angular components.
About 2019.
I like Texas for my Excel when I want to.
Hey guys, I'm Angie, the math curriculum developer. I provide the information behind some of Kema and Lidu's videos that you'll see later on. So I just wanted to take the time today to talk about a few math concepts regarding architecture, just a couple of fun facts about how it works. So maybe you guys know this, but math is practically everywhere around you, including some of the tallest buildings in the world like Burj Khalifa. Now, how does that relate to math? Well, let's say you come up with a drawing and you put it on a piece of paper. Architects would figure out like how to turn that 2D drawing into a 3D thing, and that means like how much wood am I going to need, or how how big of a space will I need between the bed that I drew here and the bed that I want. Now that's furniture, but it applies to taller buildings too. For example, the Sydney Harbour Opera in Sydney, Australia has it's like a light looking tent, but there's also a bridge because bridges are also part of what architects build. They have to figure out angles of elevation and depression and figure out how everything relates regarding like trig and geometry. It's so fun, honestly. Architects also use computers sometimes, like to code through encoding properties, because it also helps you create blueprints and initial designs that artists, have. That's how you come up with the first plan. You can't just, start building a building out of Legos. There are blueprints and interior processes. Let's think. What's another fun fact? So math forms usually include, like in architecture, usually include algebra, trig, like I mentioned, angles of depression, elevation, and algebra, trig, and geometry. The geometry part being like what's the shape of this building, the also angle of depression and elevation. And yeah, without these processes, we wouldn't even know what the golden ratio is. Now, what is the golden ratio? It's basically a geometric relationship that helps architects build things. Like I said, the relationship between, like the space between this house and this house on this piece of paper and this house in the real world. Like, we're trying to build a ratio and make sure it's the right circumstance, that when we build the house in real life, it's exactly how we imagined it when we drew it on this paper. So yeah, I hope you guys enjoy the curriculum and learn a lot about math in architecture.
Thanks for the fun facts, Angie.
Yeah, that was really insightful.
Yeah, we learned all about geometry, trigonometry, and unit conversions.
Yeah, and if you want to learn more, don't be afraid to go out and research and especially ask questions.
Time to go play with Legos.
Really, Kema? That was the last video.
Whatever.